Hello everyone, I'm Dr. Navneet Kaur from Department of Computer Science and Engineering, SIRT College, Bhopal. Today I'll be taking lecture on subject computer network. The topic which I'll discuss in this lecture is physical topology in network. Now, what is physical topology? Physical topology, it is the arrangement with which the computer systems or network devices are connected to each other. It actually decides the geometric representation of the relationship of all the links and linking devices to one another. There are basically 5 types of physical topology in the network. First is mesh topology, star topology, bus, ring, and hybrid topology. Now I'll discuss all these types in my next sections. Now first I'll discuss mesh topology. In mesh topology, every device is connected to every other device in a network. That means it has a dedicated point-to-point link which connects to other device. The term dedicated means that the link carries traffic only between the two devices it connects. Now we can see the physical structure of the topology here. Here we can see that each station is connected to every other station through a link. Now, if say there are n stations, and if I'm talking about any one station, then this station will be connected to other n-1 stations using n-1 links. Now, since we are talking about whole network in which there are n stations, so total number of links will be n into n-1. Now, if I'll consider that these links are working in full duplex mode, that means there is bidirectional movement of the data so that both the stations can communicate data packets to each other simultaneously. In that case, one link will be used by two stations which are connected at the ends of the each link. So in this case, the total number of the duplex mode links required will be n into n-1 divided by 2. Now, talking about the advantages of this physical topology, the use of dedicated links guarantee that each connection carry its own data load, thus eliminating the traffic problems that can occur when links must be shared by multiple devices. Second, a mesh topology is robust. That means if one link becomes unusable or it fails, it does not incapacitate the entire system. That means the system will continue working, it will not fail. Third, there is advantage of privacy or security. Whenever message travels along a dedicated link, only the receiver, which is intended to receive the message, sees it. Others will not receive the message. So there is a advantage of privacy or security. Now, coming to disadvantages, because here every station is connected to every other station, so amount of cabling connected to every other device is very large. So its installation and reconnection is difficult. Secondly, the sheer bulk of the wiring can be greater than the available space, which walls, ceilings, or floors can accommodate. So the hardware required to connect each link, that means input, output ports, and cable, can be very expensive for this network. Now coming to the second topology, star topology. Here, each device has a dedicated point-to-point link only to a central controller, which is called hub. Now we can say in this diagram that this is the central controller, which is called hub, and each station is connected to this hub through a port. Now, if this station wants to communicate data to say this station, last station, then first it will transmit to this hub. So this hub will receive the data from station 1 through this port. Then it will transmit to the station 4 through this port. That means Here, the data will be transmitted using this central controller, which is called hub. Here, the devices are not directly linked to one another. So it does not allow direct traffic between the devices. The controller acts as an exchange. If one device wants to send data to another, it sends data first to the controller, which then relays the data to other connected device. The advantage of this topology that it is very easy to install and reconfigure, because here every station need not to be connected to every other station, so less cabling needs to be housed, and addition, movement and deletion of the link involves only one connection between that device and the hub. Secondly, it is robust system. If one link fails, only that link is affected. All other links remain active. So it results in easy fault identification and fault isolation. As long as hub is working, we can monitor link problems and bypass defective links. Now coming to the disadvantage, we can see that the whole topology depends only on single point, the hub. If the hub fails, the whole system is dead. Also, a star requires less cable than a mesh topology system, but here each node must be linked to a central hub. So, more cabling is required in a star than in some other topologies like ring or bus, which will be discussed in further slides. Now, coming to the bus topology. Bus topology is a multi-point. Here, one long cable, which we can see here, it acts as a backbone to link all the devices in a network running between the device and the main cable. Here, each station is connected to this one long cable through drop lines, and they are making connection with this backbone cable through a tap. Now here, a drop line is a connection which is running between the device and the main cable. And tap is a connector that either splices into the main cable or punctures the sheathing of a cable to create a contact with the metallic core. Then only there will be the movement of the data. Now coming to the advantages. Here it is easy to install because here backbone cable can be laid along the most efficient path, which then connected to the nodes by drop lines of various length. In this way, a bus topology uses less cabling than mesh or star topology. Here, the disadvantage is that there is a difficult reconnection and fault isolation. If we want to include any other device in the bus topology system, now since the cable is running along the most efficient path, the inclusion of the new device will be difficult. And it will be also difficult to isolate the fault and the fault detection. Now coming to the ring topology. In a ring topology, each device has a dedicated point-to-point connection with only the two devices on either side of it. Like here we can see that this station is connected to station 1 and station 3, which are on either side of this station. A signal is passed along the ring in only one direction from device to device until it reaches its destination. Each device in the ring incorporates a repeater. Repeater is actually an electronic device which refreshes the pulse which is sent by the station or it is received by the repeater. Now here the data travels only in one direction. So when a device receives a signal intended for another device, the repeater regenerates the bits and passes them along. Ring is relatively easy to install and reconfigure. Each device is linked to only its immediate neighbors. To add or delete a device, it requires changing only two connections because here each device is connected only to its neighboring two devices. The only constraint is the traffic concentration where we have to consider the maximum ring length and the number of the devices. Fault isolation is also simplified. Generally in a ring, a signal is circulating at all times. If one device does not receive a signal within a specified period, it can issue an alarm. The alarm alerts the network operator to the problem and its location. Disadvantage here that since the ring operates only in the unidirectional mode, so In a simple ring, a break in the ring can disable the entire network. So here to fix this problem, we can have a dual ring which can travel in another direction also. So one ring will be operating in one direction and another ring will be operating in another direction, so that the entire network does not be disabled when there is a break in the ring. This is all for today's lecture. Thank you.